Good afternoon, ORI. How are you doing? And good to see so many names up there. Giant pleasure today for me to introduce my guest for the ORI anniversary series. And this is a giant of British and European robotics. His name is Paul Clarke, longtime friend of mine, CTO of Ocado till previously, and now a roving and exquisite portfolio of government advisors, startup advisors, and professionally saying no to extraordinary opportunities that come his way every day. And also a founder of the Robotics Growth Partnership in the UK as well. So I asked Paul to give a different kind of talk in that I think it's really important that we get to hear and think about why robots, why automation, why autonomy, what does it bring, what does it change, who needs it, what transformation does it bring, and how do we work with stakeholders, government, legislators to bring across that transformation. And I'm privileged in my life to meet many extraordinary thinkers about robotics and autonomy and AI, but I can count in with one finger someone of Paul's stature that has brought that kind of autonomy to your lives with delivery. We're thinking about how Ocado can make its dispatch and customer fulfillment centers and really bring robotics to the masses. So I don't need to say much more. This is going to be a very interesting and I suspect quite different talk from Paul. So Paul, thank you so much for taking the time on a Wednesday stormy afternoon to spend time with the Oxford Robotics Institute, and I'll hand it over to you. Thank you so much.
Thank you, Paul. And my goodness, how do I live up to that introduction?
A really good talk.
well, okay. Well, we'll try. We'll try. But as Paul says, or has just said, my name is Paul Clarke. I'm actually a St. John's Oxford physicist by origin. I've spent pretty much all my career as a software engineer, a technologist, and an innovator, mostly within startups. As Paul also said, I spent nearly 14 and a half years at Ocado, much of that time as CTO, leading the sharp end of their innovation factory. And now, as has been said, after leaving in November 2020, I'm now kind of focused on this sort of portfolio of government, industry, and startup advisory roles. And in terms of what brings me to here today, I was a member of the Innovation Expert Group that fed into the UK Innovation Strategy. I'm a co-chair of the Robotics Growth Partnership that Paul is a member of. I'm a member of the AI Council, and I'm also on some ISCF advisory groups, including the Robotics and AI for Extreme Environments Advisory Board. And as the title of my talk suggests, what I want to talk about today is cooking, specifically the ingredients, utensils, and recipes for transformative cooking. And I can see some of you already reaching for your mobiles to text Paul, and say things like, I thought I was attending a serious talk on robotics, but I find myself listening to an episode of Bake Off. What's going on here? But please, I do understand your concerns. We will get to the robots. But actually, I lie, because I'm not going to say that much about robots, because you know all about robots and smart machines. What I want to focus on, as Paul was suggesting, is the wider context or landscape within robots and smart machines sit, their importance as a disruptive technology, how we can unlock their true potential, and what could be so important for the UK and indeed our planet. So coming back to cooking, we all know how to bake a cake, don't we? You put your ingredients into a baking tray that has got separate compartments for things like the eggs, the flour, the butter, the sultanas, and so on, and then you just pop it in the oven. Well, obviously not. Instead, you follow a recipe, blending together those ingredients, and as they mix, their properties change, and new flavors and textures are created as they react with one another. And in my experience, successful innovation, let alone disruption, is an inherently nonlinear, messy, uncertain, risky, and frankly naughty process. Because linear, neat and tidy return on investment and data-driven recipes for innovation just don't cook well. Instead, I believe you need alchemical recipes for innovation, which embrace things like uncertainty, ambiguity, unconventionality, and failure, whilst harnessing the power of things like bold disruptive vision, serendipity, intuition, intersectional thinking, and leaps of faith. And I can assure you, this is a mindset that most individuals and organizations struggle with, let alone governments. And as a recovering CTO, you might expect me to say that innovation is all about the technologies, but you'd be wrong. Just as great cooking requires creativity, agility, collaboration, and experimentation, building and running a successful innovation factory needs those same elements, but combined with the people, the culture, the leadership, and the vision. And these factors are way more leveraged and differentiating than the technologies, and are what make innovation an art form rather than a science. And today I want to talk about the vision for a new cyber-physical, I should be able to say that by now, infrastructure for the UK, woven from disruptive technology threads that include things like data, the Internet of Things, AI, synthetic environments, digital twins, semantic maps, robots, smart machines, and living labs. These technologies are potent in their own right, but like the cake ingredients, their real power is unleashed when they react with one another in weird and unpredictable ways. And Ocado's e-commerce fulfillment and logistics platforms, which it now sells to some of the largest and most innovative retailers around the world, are woven from these same technology threads. So I have seen the transformative power of this cyber-physical infrastructure at first hand. This cyber-physical infrastructure could be important for the UK as an accelerant for research, innovation, resilience, and prosperity. However, it could also be important at a planetary scale to help us tackle some of the huge challenges that we now face as a species, including resilience to things like future pandemics and tackling other exogenous shocks such as climate change. Many of these technology threads, such as data, AI, robotics, and smart machines, will be old friends of yours, but others may be newer acquaintances. So before we start to explore this infrastructure, I need to dive into some of these technology threads in a bit more detail. And I'm going to apologize in advance for those of you who I know are out there with deep expertise in these technologies, but I need to establish a common kind of baseline of understanding and terminology, or else what I'm going to go on to talk about won't make much sense. And the first thread I want to talk about is synthetic environments, which for me is a collective name for simulations, emulations, visualizations, digital shadows, and digital twins. And synthetic environments, in my experience, are the eggs in the cyber-physical cake, binding together the other ingredients and connecting our physical and digital worlds. Now, as you know, simulations are software models, for example, of a building, a vehicle, a printed circuit board, our financial system, our natural environment, or whatever. And organizations like the Met Office have been building complex simulations of our weather systems for decades now, and simulations are increasingly in widespread use across engineering, manufacturing, and construction. Simulations can be used to help understand and optimize entities that exist, but also to model things that don't exist in order to predict and explore their potential behaviors. They can be used to generate synthetic data to train machine learning models and control systems before the real systems exist. These models, and I should say, of course, that Oxbotica is a great proponent, of using simulations to do just that. These models are built in software using a combination of maths, algorithms, statistics, physics, and increasingly machine learning to describe the entities being modeled. Simulations offer many benefits, including simulating the outcome of projects before you fund them. And my personal view is that building a simulation should be the first step in all publicly funded research and infrastructure projects. Simulating those outcomes before you implement them to reduce the risk, cost, and time to build, including stress testing for exceptions. Reducing the cost and impact of maintenance. Modeling integration of systems with their wider ecosystem to make sure they will fit together. Improving sustainability through the optimized use of scarce resources such as land, energy, and materials. And connecting AIs to simulations to enable them to get physical and to explore virtual worlds to create designs and optimizations whose complexities are completely beyond human scale. But simulations can also be used to create immersive environments for education, training, and reskilling, potentially in combination with technologies such as VR and AR. For example, a flight simulator enabling pilots to learn how to fly a new aircraft, including responding to emergencies such as a bird strike or engine fire. Now, emulations are higher fidelity or more accurate models of a physical entity that represent the behavior of the actual hardware. For example, modeling the internal components of an engine and how they actually move. To achieve this greater accuracy, emulations have to worry about physical complexities such as friction, gravity, statistical variation in the behavior of components, and so on. But by more accurately representing the hardware, emulations allow you to run the production software on top of the emulation. For example, the emulation of a car engine, enabling you to test the engine management software before the real engine exists, thus speeding up the development lifecycle. Emulations can include components of the real hardware. For example, when designing a car, you might start with a completely digital model, but then perhaps replace the emulation of the dashboard with a real dashboard, enabling the designers to actually interact with it. This is called hardware in the loop emulation and allows engineers to gradually move from a fully digital model to the final physical product or service. Visualizations are visual representations that bring data to life, whether those data come from a simulation, an emulation, digital shadow, digital twin, or indeed the real production system. Visualizations help increase understanding, generate insights, and manage complexity. For example, in a complex system, you can tell the visualization to only show you the specific elements you're interested in so that you can see the woods for the trees. Visualizations are typically constructed as an overlay of multiple layers, with each layer representing different aspects of the physical system. For example, a visualization of an aircraft might be split into layers for things like the airframe, the control surfaces, the wiring, the hydraulics, the control systems, and so on. They enable you to ask questions you couldn't even answer if you were next to the physical system. And you can ask the visualization to do things like take you to a particular moment in time and then to play the visualization backwards or forwards from that point. Now, if you connect a real-world entity to the simulation or emulation that's modeling it, so that data can flow, often in near real time, from the former to the latter, then you've created a digital shadow. A well-known example of digital shadows is a weather forecasting model fed with data received from numerous weather stations and sensors around the world. Now, there's a lot of talk about digital twins at the moment, but the term is particularly misunderstood in my experience, meaning many different things to different people. According to my definition, simulations or emulations become digital twins when you bidirectionally couple them to their physical twin. So imagine you wanted to optimize traffic flow around a city such as Oxford. Well, you'd probably add cameras and sensors to the traffic junctions to record the information flows about vehicles, people, cats, pollution levels, and so on. You'd then build a simulation of the road network, traffic lights, cars, people, and cats. And you'd stream all the data from the cameras and sensors to the cloud, and from there into the simulation. Well, now you've created a digital shadow, which you could use to run studies, to optimize things like the timing of the traffic lights, the impact of future roadwork topologies, or alternative road layouts. But then you might update the timing of the actual traffic lights with the optimized settings. And now with that bidirectional coupling, you have turned your digital shadow into a true digital twin. In Ocado's robotic hives, there are 3 levels of machine learning at work. There's the intelligence they're building into the robots themselves, the purpose of self-test, troubleshooting, and exception handling. So if one of them has a problem, how do they wiggle their fingers and toes to find out what's wrong and either fix the problem so that they can join the swarm or else go into the pits for a service? And then there's the real-time orchestration and optimization of the robot swarms and their associated grocery storage. And this is performed by a complex machine learning-based air traffic control system. There's the 2D optimization of the robots themselves, and then the 3D optimization of the storage underneath them. But because they're doing this optimization looking forwards in time, it's really a 4D optimization. Where's the best place to put back a bin of cucumbers based on when you'll next need it? And the answer to that question is changing all the time as new orders come in from customers and new bins of cucumbers arrive from suppliers. But these robots are a great example of mobile edge computing. Each robot generates about 5,000 data points 1,000 times a second. So if you do the maths, that's about a gigabyte of data per robot per day, or about 4 terabytes per swarm per day, and that's in just one warehouse. With swarms of robots in warehouses around the world, there's no way that human engineers can look after the monitoring and oversight of all these robots and their data in real time. So all their data exhaust is streamed to the cloud, and there, Ocado has built the third level of intelligence, a machine learning healthcare system that looks after the members of the swarm and attempts to keep them in tip-top shape by spotting the onset of problems before they become problems. And this, you could argue, is directly analogous to what we can do in terms of remote medicine for humans, using patient records, data from wearables and other sensors in the home. But in Ocado's case, the patients are, of course, robots. And Ocado uses these data that they harvest to feed the digital twins that optimize these huge automated warehouses, the routing of its delivery fleet, and other elements of its e-commerce fulfillment and logistics platforms. And if you haven't worked out, the top video here is the robotic hive, and the bottom video is its digital twin. Now, Ocado recently announced a swathe of radical innovations to its fulfillment and logistics systems, including a new 600 series robot that is largely 3D printed. And the development of this robot made extensive use of simulation, as did previous generations, but also topology optimization techniques. And if you want to find out more about this exciting stuff, you can just search for Ocado Reimagined, and there's a video of it. Now, if you're interested in reading more about digital twins, there's a blog I wrote about Ocado's journey with synthetic environments for the Cambridge, data-centric engineering department. You just need to search for DCE Paul Clarke to find it. But the real power of digital twins comes when you connect them together. And for an example of connecting digital twins, you can think of an aircraft airframe, its engines, its control surface, and so on, that you might connect together to create a digital twin of a complete aircraft. Then connecting the digital twins of an aircraft, airlines, air traffic control systems, airports, and many others to create a digital twin of the aviation sector. Adding in digital twins of the roads, railways, and seaports to create a digital twin of the transportation system. Then adding in digital twins of the energy network, logistics network, consumer demand, and so on. And if we were to keep going on this journey, we would eventually assemble a digital twin of the UK. And this is the vision for the National Digital Twin Programme that's being led by the Centre for Digital Built Britain and supported by many other stakeholders. The next step on this journey would be to build planetary digital twins, and a growing number of organizations and stakeholders such as myself are proposing that we should build digital twins of our planet to help us better understand our environmental systems, but also to reduce the impact of our man-made systems upon them. These visions will require us to stitch together our digital twins horizontally and vertically. Digital twins that have been built by different organizations for different purposes, with different technologies, and constructed with different levels of fidelity and abstraction. This will require the development of a digital commons in the form of shared standards, ontologies, interfaces, and middleware to act as the smart glue that connects these digital twins. And the Centre for Digital Built Britain have been working on an information management framework to do just that. Now, one day we may be able to build digital twins of people, personal digital twins. These could obviously be very useful in areas such as healthcare, but they would, of course, raise all sorts of security and ethical issues. And if that idea worries you, the good news is they're a long way off, because as things stand, we struggle to model the physiology of simple plants, let alone that of humans. Now, synthetic environments enable us to construct entire virtual worlds. An example of this are video games like Grand Theft Auto and Roblox. And all of the actors in those games, such as the people, the weapons, the cars, and so on, are individually modeled, and physics engines are used to make sure these actors move and behave in realistic ways. These virtual worlds are so sophisticated and realistic that autonomous vehicle manufacturers, no names mentioned, often use them to test their software. And there's a growing level of chatter now about the concept of a metaverse, virtual worlds in which people might meet, shop, hang out with friends, earn money, and so on. And the large technology companies and hyperscalers have different and often competing visions for what these virtual worlds might look like and the services they would provide. But in general, they are about harvesting our data and generating revenue. But what I think is potentially much more exciting is the possibility of using these virtual worlds as immersive spaces for learning, collaborative innovation, and problem solving, with access to greater diversity of thought, skills, and experience. I also believe these virtual worlds could have a very important role to play in tackling climate change. Some of you may remember the concept of, remember a game called Sim City that allowed you to model and optimize the way a city worked, or Sim Roller Coaster. Well, what about a Sim Earth game that could help drive understanding of climate change and of the personal decisions that we need to make as citizens, but also to actively nudge our behaviors? Now, three important missing elements of our innovation ecosystem include: how do we visualize data at a national scale to bring them to life, to generate insights and understanding, to manage complexity, and to, as I just said, nudge behaviors and so on? How do we crowdsource data from sensors and other sources, particularly the real-time data about our infrastructure, systems, and public services? How do we use interactive and potentially immersive digital tools to foster communication, coordination, collaboration, and innovation at a national scale? Now, for nearly 3 millennia, geographical maps have been used to chart territories and aid navigation. These maps capture and visualize physical entities, their spatial relationships, and the geographical topologies within which they reside. However, in their more generalized form, maps aren't just about geospatial data. For example, the map of an organization might convey more abstract information, such as the relationships between stakeholder groups, the contact information for individuals, the management hierarchies, and so on. These data can be connected by semantic relationships such as is like, can be, needs, influences, knows about, could help, and so on. Such maps are often referred to as knowledge graphs. Maps can be used to capture and visualize all sorts of landscapes and to help users navigate them. Digital maps provide additional functionality such as personalization, search, filtering, animation, live and crowdsourced data, layering, and so on. These sorts of features help manage the complexity and scalability of visualizing large, multi-dimensional data topologies. Now, the construction industry takes such layered maps for granted in the form of engineering drawings for things like power, plumbing, HVAC, networking, building management, and so on. However, I would argue that we aren't just trying to construct a smart building without them, but rather we're trying to build and operate a smart country without them. And the above missing elements could be addressed by a new piece of digital infrastructure to enable the controlled and secure creation and sharing of semantic maps at a national scale. These maps will be dynamic, online, interactive, living entities, visualizing data from sensors, infrastructure, public services, models, and many other sources. They would support the controlled and secure crowdsourcing of data, including the plumbing in of live data sources. Some maps would be geospatial in nature, but others would be knowledge graphs based upon connecting data via semantic relationships. Scalability, accessibility, security, privacy, and ethics, and trust would need to be baked in by design, with AI-based moderation, monitoring, and management being a key ingredient. The content within these maps would be assembled in layers to both manage complexity and implement privacy and security, with connections being made both within layers and between them. These so-called maps would provide users with many different ways to consume the underlying data, such as heat maps, configurable dashboards, animations, simulations, alerts, and so on. These maps would help visualize complex systems of systems and how they interact. For example, our food system and how it's connected with healthcare, environment, logistics, power distribution, international trade, and so on. They would act as a data store for other applications. For example, the component digital twins within a UK digital twin might consume the data, and the maps would provide the twins with the topological context within which they sit. These maps would help inspire citizens about the potential power of data to drive understanding, generate insights, nudge behaviors, and other outcomes for good. They would help people understand what exists and what is missing, if you like, visualizing the dark matter that lies between what is known in order to foster greater intersectional thinking. And by acting as an exemplar for the secured and controlled sharing of data, with a strong emphasis on privacy and ethics, these maps could build trust and encourage systems to share their data for public good. As I've been illustrating, you can do a lot in synthetic environments, but eventually you need to move to the real world to test the sorts of things we struggle to model digitally, such as public acceptance, ethics, privacy, and trust. And this is where living labs come in. They're an experimental environment that are representative of the real world, but initially more constrained, where you can safely test your immature product or service, a bit like fitting stabilizers to a child's bike. As the product or service matures and your confidence increases, you can then loosen the constraints until you eventually close the gap with the real world. Living labs are often confused with technology test beds, but they are fundamentally different. Test beds are all about consistency and repeatability, whereas living labs are about diversity and unpredictability. They're about learning by doing, often delivering real services to real people. And it is the people that create the diversity and the unpredictability. Living labs are a solution pattern that is applicable to many different problem domains, including autonomous vehicles, AIs, digital twins, and so on. And we need to use the UK as a country scale living lab, both to generate new products and services for ourselves, but also for export. As you know, smart machines is a collective term for robots with embedded sensing and intelligence, including ones that move, such as autonomous vehicles and drones. And these smart machines may exhibit behaviors such as navigation, inference, threat avoidance, exception handling, self-repair, autonomy, and so on. And just like digital twins, the real power of smart machines comes when you connect them together or federate them so that they can be orchestrated as a swarm, such as these illuminated drones painting images in the night sky, or a swarm of robots in an Ocado warehouse. But just like humans, engineered smart machines don't just burst into the world as mature adults. Their conception and gestation is normally within simulations and emulations. Then gradually they're exposed to aspects of the physical world using test rigs, hardware in the loop emulation, and external sensors to capture real-world data. The next step is to allow them out into the world, but within constrained environments, those living labs. Eventually, the smart machines can be allowed out into the real world. But even then, teleoperation enables humans to scalably step back into the loop and take control if and when the smart machine encounters a problem that they cannot solve. And as a parent, this is rather like the watchful eye that you have offering advice and assistance to your children during adolescence and even adulthood. And a digital twin of the smart machine can then accompany it throughout its lifetime, helping to optimize its behaviors. Now, most of the current generation, as many of you will know, of smart machines can only perform one or two specific tasks, such as hoovering your carpet, mowing your lawn, or amusing your children. But much of the cost of these smart machines is sunk into their sensing, vision systems, and compute power, which is duplicated across different smart machines. So what would be much more cost-effective would be to have smart machines that can adapt themselves to perform multiple tasks that are extensible and maintainable, a bit like a dog that you can teach new tricks, or indeed a transformer. And achieving this evolutionary capability will require modular software and hardware designs built upon common standards for their components and interfaces. And this in turn makes the case for companies collaborating on the design of those pre-competitive shared building blocks, both software and hardware, for constructing these smart machines. Now, social science is a vitally important ingredient in the technology cauldron, but is often overlooked. How will somebody feel when a robot covered in sensors and cameras comes to their door to deliver a parcel, to fix their washing machine, or to work alongside them in a smart factory or construction site? What should it look like to engender greater trust? What are the privacy issues relating to the data that these robots will be collecting? And that's why, as I said earlier, we need privacy, security, and ethics and trust baked in by design. And as I explained with Living Labs, we need people involved throughout that innovation lifecycle. So let's switch analogies from cooking to exploring. Another way to look at innovation is that it's like exploring an uncharted territory. And a successful expedition over this non-linear and unpredictable innovation terrain requires a number of things, including a bold, expansive vision for where you hope to get to, the strategies that you'll adopt, and the potential routes that you'll follow along this journey, the equipment, tools, and competencies you'll need, the infrastructure that will support your mission, the team that will accompany you, and how you will collaborate with one another, the ethical, safety, regulatory, and other issues that may guide your exploration, and so on. Now, we may need to start with planned missions during which we reach vantage points that enable us to spot other potential areas of interest that were previously invisible to us. And then we're going to need off-piste explorations that might come with greater risk and uncertainty and often require different equipment and competencies. It's these off-piste explorations that are analogous to the opportunities that lie at the intersection of different technologies and disciplines. It's at these intersections that we may discover the transformative innovational dark matter, and yet our educational curricula, research institutions, research funding programs, and government strategies normally relegate these technologies and disciplines to their individual silos. Think back to those components in the cake tin. Those compartments, rather, in the cake tin. When climbing a mountain such as Everest, you're going to need to establish the infrastructure to support your expedition, such as the camps that and the supply chains you'll establish along the way. And when it comes to innovation, this is the role of research institutions, and there is a special breed of such institutions that are or were focused on intersectional thinking and exploration. For example, the Santa Fe Institute, the MIT Media Lab, Bell Labs, Xerox PARC. And indeed, we need some of these institutions in the UK. This dual on and off-piste strategy is an example of how innovation needs to be a managed spread bet across different time, risk, and technology horizons, with separate compartments focused on those different horizons, but separated by semi-porous membranes that allow things like people, ideas, competencies, and ways of working to flow between them. Now, the UK is competing with some much bigger players who have more data, more resources, more money, and often political advantages over us too. So as a nation, we need to create leverage and defensible competitive advantage by equipping ourselves with the tools, infrastructure, and strategies that will enable us to explore this innovation landscape faster, smarter, with less risk and lower cost. I'll come back to talk about the infrastructure and the tools, the cooking utensils, if you like. But in terms of the recipes, there are some different ways of thinking and working, which for me are embodied within a set of innovation solution patterns, or you could say innovation superpowers. Intersectional thinking, exploring that innovational dark matter I just mentioned. For example, networking, hanging out and collaborating with people from radically different domains that may make absolutely no sense on paper, but who will potentially challenge, extend, or disrupt your thinking. 10x thinking, looking for completely new ways to solve a problem that would not deliver 10% incremental benefits, but 10 times improvements. 10x solutions are often based on technologies that either don't exist yet, are too expensive, or not sufficiently performant. So they are often a calculated bet on the future, and they're a way of looking for innovation wormholes. Russian doll thinking. You need to focus not just on the current challenges and opportunities, but on the ones behind those and the ones behind them. What I would call first derivative thinking. An example of this from my world is that it's not just about the robots, but about the robots that will make and maintain the robots, and the robots that will construct the factories where the robots that make and maintain the robots are themselves made, and so on. It's about scalability and sustainability by design. Cyber-physical thinking. We often focus on our digital and physical worlds rather than seeing them as a cyber-physical ecosystem. However, where our digital and physical worlds collide, live magical beasts such as digital twins, smart machines, and living labs. And it is at this cyber-physical intersection that the really exciting things happen. For example, tackling climate change is going to require cyber-physical interventions at a truly planetary scale. Design thinking, when innovating, your ideas and potential solutions are often at their most messy before clarity emerges. It's like the fuzzy states within a quantum computer before it collapses to a single low-energy solution. Design thinking can help bring some method to the madness, but we really do need to be aware of trying to tidy up that messy process too much. Systems thinking, seeing the world as the complex web of interconnected systems and ecosystems that it is, and the role that modeling can play in helping us unravel this complexity. Ecosystems thinking, living labs depend on ecosystems. Sorry, living things depend on ecosystems. So do living labs, which have many moving parts with complex, nonlinear, time-varying interdependencies and interactions. For example, healthy plants need healthy soil, and this takes time and effort to establish and nurture. Similarly, the evolution of AI, smart machines, and synthetic environments depend on ecosystems that include research, technologies, components, services, and competencies. Ecosystems that also require investing and nurturing in their own right. And last but not least, platform and smart services thinking. We are on an evolutionary journey from own to rent to share to everything as a service. This journey is important not just in terms of economics, but also to drive greater sustainability. Smart services powered by AI and digital twins are the powerful but often overlooked ingredient because they help to drive orchestration, optimization, and business model transformation. If I can digress briefly into something that is near and dear to Paul's heart, if changing existing vehicles to be electric vehicles will help with pollution, making them autonomous will be great for the service operators. But if we want to tackle things like congestion, improve the quality of the services we provide the customer, and radically transform the way our transportation system, including across multimodal mechanisms such as land, sea, and air. Now we need platforms and smart services to do the orchestration and optimization, to do the cross-sector, cross-competitor sort of collaboration and transformation, and to drive that business model transformation. Because at the moment, pretty much everybody is just doing their own thing, and that's simply not going to work. So, but this same ingredient of thinking in terms of smart services applies to many other problem domains too. Now, the pandemic has been a stern tutor, teaching us all sorts of lessons. For example, the need for much more data, including real-time crowdsourced data relating to the behavior of systems, infrastructure, and systems. The need for better tools for remote collaboration. And what we need is much more than just video conferencing. The need for much better tools for immersive remote learning and training. The importance of all sorts of models and simulations that we didn't have. That we're missing all manner of smart machines to do things like safely clean our hospital red zones, to support agile configurable manufacturing of things like PPE, and to power orchestrated autonomous scalable logistics for critical supplies. And finally, the fragility of our man-made infrastructure and systems has been exposed. Because if you can stack 3 boxes of animals in the wrong order in a Chinese wet market and bring down a planet, at least in terms of the dominant species, then we clearly have a lot to fix in terms of resilience, and it's at a national scale. The solutions to these challenges are some of the tools we failed to build in the previous peacetime, not because nobody thought of them, but because they simply weren't prioritized. Well, now we're going to need to build them in the next peacetime. The countries that have arguably coped best with the pandemic often had the best tools rather than the best plans, enabling them to be more agile. Peter Drucker was right when he said that culture eats strategy for breakfast, but I would argue that agility eats planning for lunch. We need these tools not just to prepare for future pandemics and other exogenous shocks like climate change, but also to power greater prosperity, resilience, diversity, and sustainability during normal times. Tools to help us explore that innovation territory smarter, faster, with less risk and cost, as I mentioned earlier. We need to reframe our concept of infrastructure. Infrastructure is not just buildings, roads, railways, and fiber broadband to rural communities. It's also the enabling cyber-physical infrastructure that's often overlooked. And big initiatives and missions lack the time, budget, capabilities, and often the vision to build this sort of horizontal enabling cyber-physical infrastructure themselves, let alone to support other initiatives. So a growing coalition of the willing, led by the Robotics Growth Partnership that I co-chair and which Paul Newman is a member of, have been engaging with the government and other stakeholders on a vision for national cyber-physical infrastructure. Here are some of the elements of this infrastructure. A new open source framework for building synthetic environments to make them an affordable and accessible commodity, especially for startups, SMEs, and the public sector. Smart glue in the form of the digital commons for connecting digital twins and smart machines into powerful ecosystems at a national and even planetary scale. Pre-competitive shared cyber-physical building blocks for creating all manner of new smart machines that, once woven into the fabric of our everyday lives, will deliver prosperity, agility, scalability, and resilience and sustainability during normal times, but ready to be conscripted when exogenous shocks strike. Virtual worlds providing immersive environments for lifelong learning, training, and reskilling that not only transform the educational experience, but also provide leveled up access by anyone from anywhere. And cyber-physical campuses, physical spaces, but with immersive remote access that pull together a blend of many stakeholders, including researchers, entrepreneurs, investors, regulators, students, and the general public. So what would the benefits of such a cyber-physical infrastructure be? Well, a bit like the World Wide Web, it's almost impossible to predict all the first order, let alone the second and third order benefits. And just as when Tim Berners-Lee went around with his white van persuading academics to connect their service to his vision of a World Wide Web, I can assure you it was not based upon a detailed business plan. It was a bold vision and a leap of faith. However, here are some of the potential use cases for this cyber-physical infrastructure. Innovation. Researchers, inventors, and innovators across multiple industries accessing immersive virtual environments to ideate, design, and test new products and services. Working individually and collaboratively across organizations, the UK and internationally. Conducting virtual experiments in virtual labs and with remote access of robots in physical labs. Accelerating their innovation by pulling in shared, pre-competitive, tested building blocks into their designs, testing their digital prototypes in virtual worlds before fabricating them in robotic workshops, testing physical products and services in living labs to engage systems and gain the trust of regulators. Healthcare, digital twins of patients, primary care, hospitals, and trusts, ultimately the NHS as a system of systems, transforming the quality and scalability and sustainability of healthcare provision. Remote monitoring of patients in their homes, delivering greater freedom and predictive interventions. All manner of smart machines, improving safety and efficiency in areas such as surgery, logistics, cleaning, and even social care. Food, building digital twins of our food system, including measuring and modeling the externalities of conventional agriculture that are largely hidden and generating environmental debt for future generations. But also modeling and developing new alternative forms of agriculture to turn photons into calories into calories and proteins in sustainable ways. Logistics, swarms of clean energy powered smart machines on and under the land, on and under the water, in the air and even in space, transforming how we move people and goods around our planet in more efficient, scalable and sustainable ways. What I was talking about earlier, which I refer to as building an internet of freight for the UK, or maybe the planet. These machines would be both autonomous and orchestrated by smart services powered by AI and digital twins. And as they move around, these smart machines can also collect valuable data to help optimize services and reduce environmental impact. Entertainment. New forms of immersive entertainment built around weaving together synthetic environments, AI, and smart machines, transporting us to new virtual worlds we could never visit, but also enabling exploration of those parts of our planet that most people could never afford to visit, or that we have to stop visiting so much to reduce the environmental impact. New forms of immersive collaborative art and drama with increased diversity in terms of their content and audiences as a result of being accessible between different societies, cultures, countries, and time zones. And all of this at the core of the UK's contribution to international collaboration on cyber-physical services at a planetary scale to help deliver on our net zero and sustainable development goals. Harnessing data, AIs, and digital twins to increase our understanding of our natural environment and to reduce the impact of our man-made systems upon it. And then orchestrating swarms of clean energy powered smart machines to help monitor, clean up, replant, and repair our planet. This is a very big, bold, and expansive vision. It's a horizontal Earth shot, if you like, but it would be built incrementally in a number of agile steps with tangible benefits delivered along the way. One of these initial steps would be to build the shared foundations, including the architecture and standards required to bake in interoperability, security, privacy, ethics, and trust by design. By using its convening power and investment in research and innovation to deliver these foundational elements, the government could stimulate crowdsourced innovation, venture investment, and adoption by the public and private sectors. The cyber-physical infrastructure would be a piece of shared enabling national horizontal infrastructure to support many missions and moonshots, an infrastructure that stitches together our physical and digital worlds, and an infrastructure that could be as transformative as the World Wide Web. The UK, we believe, has the opportunity to take the lead in developing this infrastructure for its own needs, whilst at the same time establishing international standards that could support collaborative innovation with other nations on planetary scale challenges. This cyber-physical infrastructure made it into the UK innovation strategy and was published, last summer, and it was formally launched last Friday on the 11th of February by George Freeman, the Minister for Science, Research and Innovation. The publication is now available on the Gov UK website, and I will post links to documents into the chat later on. And the next step on the journey is that the government was going to be launching a formal consultation process to explore this opportunity. But to finish, there is a much bigger picture that we need to focus on. My personal view is that the pandemic has just been a dress rehearsal and hopefully a wake-up call for the challenges ahead that we face as a country and as a planet. So we need to think bigger, much bigger, as individuals, as organizations, as a country, and indeed as a species. We need big, bold, holistic, long-term visions for the future of our country, our planet, and our species. We need new political, democratic, and ethical frameworks to drive decisions and actions on behalf of our planet and our species, and indeed the ecosystem of species that we coexist with, both now and on behalf of future generations. We need new ways of thinking, acting, and collaborating that can transcend national borders and self-interest in order to drive innovation on behalf of our planet and our species, rather than just the vested interest of nations and shareholders. And given how late we have left it, arguably 1 minute to midnight, we need new tools to help us to solve these challenges smarter, faster, cheaper, and with greater coordination, collaboration, and diversity of thought. We need to stop behaving like a bunch of squabbling tenants who haven't been looking after the building properly and are now surprised that we're facing eviction. We need to get our shit together, and to do that quickly. We need to assemble the ingredients, utensils, and recipes that can enable us to transform the way that we cook as a country and as a planet. We need, I believe, cyber-physical infrastructure. Thank you very much indeed.
Yay, super. There's much silent clapping. Thank you so much, Paul. So I've got a heap of questions that we can kick around, but I'm wondering if I can open the floor up to some ORIers who might have some questions. Now, I can't see everyone, so you might just have to start speaking. See if I can go to a view where I can see some hands. Okay, well, I can't see any hands. So I got a question. So you're king tomorrow, okay? So almighty Paul Clarke, and you've got the budget at number 11. What are you going to build immediately? Physically, what doage will you do next week?
So, as you may remember, we ran a very successful summit on this topic last summer. And that was really to try and start pulling together a kind of a wider coalition of the willing and the doing. And so I think one of the things we need to build upon that, and obviously the kind of formal consultation process the government's going to do will help do that. So that's one thing. As I said, I think the most important thing is to build the foundations. And I mean, just in the same way that when you build a house, you don't just build the foundations for one room. You need to think about the plumbing and the shared services that flow across. So we need to build those foundations, the standards, the ontologies, the APIs, the middleware, the shared building blocks, and so on. And I see that as the really important part. And there's a lot of work to do on that actually isn't about spending huge amounts of money. It's about a lot of thinking. It's a lot of getting a lot of smart brains on that, a lot of talking to people. And once those foundational elements, or at least the engineering drawings, if you like, for those foundational elements are in place, then in a sense, people can start thinking about building the layers that will sit on top, the rooms. And so, but if we don't do that foundational work and everybody goes off doing their own thing, then we will have a kind of a VHS Betamax challenge, you know, for those people old enough to remember that, at a monumental scale, and that will not be good. And so
really
I see that as
governments. I mean, that's a really hard thing for a government to make the nudge, to make space for big players, small players, put enough of a framework that it's not going to be the mess that was telecommunications in the US, for example. There's any number of examples, and like, yes, we built motorways and we built infrastructure, but we weren't quite so. I'm playing out as your provocateur here because, you know, we're on the same side, so it's stimulating the debate.
It's always fun.
We didn't build the internet with the deliberative purpose that you're talking about that's needed here. It was somewhat more emergent, right? So do you think this is a harder case?
But I would argue that what we did do, or which, you know, ARPA and others did, you know, ARPA did, is establish, you know, an extensible architecture, you know, that could scale, that could federate, that could allow you to connect different devices. Now, of course, we got plenty of stuff. Well, I'm not going to say we, because I was quite young then. But, you know, looking back, we can see that we got quite a lot of things wrong. I mean, particularly, you know, around what we see playing out now, you know, in terms of, you know, ethics and trust, and, you know, who owns what, and you know, what, you know, inevitably the, you know, the arms race for what bad things we can think of doing on it, as well as the good things, you know. So definitely there are lessons to be learned, but I do think that fundamentally, you know, there's a lot of the architecture that was got right. I mean, of course, things had to be extended, and probably I'm sure Tim, when he went around, wasn't thinking, well, in, you know, 30 years time, there's going to be a pandemic and we're going to be jolly lucky that we've got a World Wide Web, you know. But the point is, you know, so we have to assume that if this is successful, you know, it's going to have to scale like mad, and therefore, you know, there's a lot of things to get right there. But anyway, you know, architecture is king, as always.
Yeah, Morris, thank you, Paul. Morris, you had a question.
You've kind of wandered through my question, but maybe more specifically, you know, the invention of social media, the Facebook et al. Kind of corporatized personal communication, hid it behind proprietary walls, which wasn't in the public interest, or wasn't developed in the public interest. What efforts do you think could be made to ensure that something like you're describing could be in the public interest, instead of repeating what happened previously? Well,
I mean, it's certainly a topic we've talked, you know, about a lot, but we've certainly got to talk a lot more about. I mean, my view, I suppose, just, you know, even if we leave virtual worlds to one side, you know, my view on social media is that actually, when it comes to things like climate change and pandemic, you know, it could be an immense power for good, but I would argue that we probably need a new kind of social media that is actually, you know, about how we engage citizens at a planet scale, but, you know, for good and for collaboration and for getting as many brains on difficult problems as possible. And, you know, in the slightly frivolous way, I will come back to answer your question, but, you know, when NASA did its first moonshot, you know, a whole bunch of people didn't think, oh, you know what, I'll do that part of the lunar lander, and I'm going to do that part of the Saturn rocket based on what I've done before. And, you know, we're not going to agree on a launch date. We'll just come together at the same time, and everything will magically fit together. Well, of course, you know, that's not how it happened. It required an immense amount of leadership, engineering excellence, serendipity, blah, 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 by NASA and JPL and so forth. Well, I would argue that we're trying to tackle things like climate change as if with everybody working on what they fancy, with no real centralized kind of governance, it would be an absolute miracle if it all fits together. And what's more, it would also be a miracle if the best brains happen to be aligned with geographical boundaries to work on different problems. So I think we need to be able to drive planetary scale matrix management, if you like. We need to get the best people focusing on the best problems. And I think cyber physical infrastructure could be part of that. I think metaverses could be part of that, but good metaverses. I think, new forms of social media for problem solving and coordination and collaboration, which are in public ownership, could be part of that. But yeah, what they all share in common are the challenges around cybersecurity, around privacy, around ethics, around trust, and therefore, those strands, we have to get right. But I don't have, coming back to your exam question, I don't have the magic answers to those questions yet. But what I can tell you is they are front and center of what we are thinking about, because what we don't want to do is to create something here that, ends up being, weaponized. Of course it will be, but we have to try and minimize those unintended consequences. But there's a lot to do in that area. And there's also, that comes back to the living labs thing. There's a lot of learning by doing, because I think there's a limit to how much we're going to get right. Just trying to think it through. Modeling will help, war gaming, all that kind of stuff will help, but learning by doing is a key element.
Okay.
Thanks. I haven't got any other questions, but I've got a question that might be different, and it's quite practical, Paul, in that probably most members of the institute don't know actually the work that happens and how you engage stakeholders and government to have these conversations. And that's probably quite transparent. And we talk about, we had these conversations, we were in this place and we said these things. It might be just quite interesting in terms of sort of career development for members of the institute to hear a little bit about what kind of meetings we go to. It's quite a practical conversation. I was thinking about where people are in their careers, and the kind of things that we might do, and what venues you have at, who do you pitch at, how do you try and get purchase of this? Because we're actually talking about something phenomenally complicated. There's one side of the tech, sure, but then there are like a whole series of nudges that you have to make at the right time.
I'm going to have to do this super fast. And the reason is I've actually got to go to one of those meetings.
I'll go and do a nudge.
On semantic maps in just a second. But I mean, you're being hugely humble here, Paul, because you know this journey incredibly well, because you've done it with, around autonomous vehicles. And the answer is, it's a bit like, I would say it's a bit like trying to bring the walls of Jericho down. You have to hit the right parts of the system in the right order with the right cadence, and you have to keep on doing it until you get resonance. Because I could, as you know well, and I certainly know well, and have the battle scars for it, this is very difficult. This trying to drive transformational change, especially in areas that are cross-cutting, which cut across different government departments, which cut across different disciplines, which cut across different technologies, is all the more difficult. And it's like a mammoth kind of, I don't know, synchronized swimming and plate spinning exercise in one, and but you need endurance, and you need vision, and you need to just keep going. But, and if it was easy, obviously lots of people would have done it already. But I'm really happy if people have got questions on that stuff and they want to fire them to me afterwards. I'll do my best to answer them. I'm really sorry. I'm going to have to dash. Thank you very much indeed. And thank you for inviting me.
Okay, real pleasure. Take care, Paul. Go do some nudging.